All right. Hello, everyone. Welcome to our third online lecture. Today we'll be talking about 2D lists and testing, which is something that we're going to be using for the next project. So, in the past, we used to do design documents for projects, and this semester we have a kind of new experiment that we're going to run on all of you. The experiment is going to be that you're going to write little test script files and submit them. So we'll either cover that today or tomorrow. Today we're going to do at least two-dimensional lists, and I'll spend hopefully a good bit of time on that. Okay, so let's begin. Okay, well first let me Okay, so what is a 2D list? And the answer to that is really that we've been kind of using 2D lists off and on since the beginning of the time when we've had lists, mainly because sometimes I've shown you that you can have lists within lists. So a 2D list is a list within a list. So let's do an example of a 2D list. So let's create my first 2D list, and that's of course a little bit of a lie, but whatever. Here's an example. That's a 2D list. And so the question is, the first thing we want to talk about is what does all of this mean, right? So we have two sets of brackets, and inside of the first list we have a list in the first slot and a list in the second slot. And so the question becomes then, how do we access elements, right? And so with if we were to print out my first 2D list 0 and print out my first 2D list 1, let's just see what we get when we do that. So when we print out the 0 element, we get the sublist 1, 2, 3. And when we print out the 1 element, we get the sublist 3, 4, 5. Okay, so note that if we print out this thing sub 2, we should get an index error. Yep, because there's nothing in the second slot. Okay, so let's get rid of that. But this is not really how you want to use 2D lists generally. You do want to access sublists sometimes, but you also want to access specific elements. So let's print out my first 2D list. Let's print out 1, 1 and see what happens. And then we'll print out, say, 0, 2, and then we'll print out 0, 0. Okay, I guess we'll print out 0, 0 first so that it makes sense. All right, so what do we expect to get? Well, with 0, 0, what we expect to get is we go into the first sublist because we're going in for index 0. And then in that sublist, we expect to index the 0th element. So we expect that this should give us 1. All right, so let's see what happens. What do we get here? So here we're going to go into the next sublist, but we're not going to access this element. We're going to access this element. Whoops. And finally here, 0, 2 will access the first sublist. And yeah. And then here we're going to access the last element. All right. So let's just run that and make sure that it does what we expect it to do. If it doesn't do what we expect it to do, then obviously we or it are expecting the wrong thing. Okay, there we go. So All right, so we see how to access now, right? Okay, cool. So what else can we do with 2D lists? I think one of the primary applications of 2D lists is, and let me just put this into a function. That way we can not have it run. Why don't we talk about a little bit more with indexing. So let me make a 4x4 grid of numbers. So let's, define our weird indexing, of course. Okay, so new list is equal to, say, let's put a bunch of numbers in. 1, 4, 6, 2, fine. 3. And well, I guess that would be a little hard to tell apart. Let's at least make them different. And then, okay. So here now we have this new list. So there's nothing wrong with having, I shouldn't say that there's anything wrong with having multiple elements in the same list. I could define this whole thing to be all zeros or all ones. The only reason why I'm defining them to be random things is so that when we access various elements, let me just add some randomness to it so that it's a little bit, so we know where we are exactly and not just guessing. That was weird. Okay, cool. So now, this is basically a type of question that we usually ask on exams. I don't know if we'll ask this type of question again on exams, which makes it even more important that you guys practice this a little bit. So just go like new list and then say 3, 2, and we'll print that out. And then we'll say new list 1, 3, new list 2, 2, and say new list 0, 3. Sure. Okay, so let's just make sure that we all agree on what all of these are. So, okay, what do I think this first one is? So remember, what we have to do, oh, is there an extra set of brackets here? I think there is. That was a list within a list within a list, so that would have been a little bit dangerous. It's not exactly what I intended. I think it's fine now. So here what you do is you count that this is the 0 sublist, this is the 1 sublist, this is the 2 sublist, and this is the 3 sublist, right? Yep, so I'm seeing a lot of people saying that this is, and by a lot, I mean 3 so far, but that's a lot. Yeah, it was a 3D list. So 33 is the answer to this one. All right, so let's look at the other ones and make it a little less boring. So here, we go into the 0, 1, so this is the 1 sublist, and then we look for the third element, so 0, 1, 2, 3, so we get 1. Okay. Cool. So now let's look at the 0, 1, 2 sublist. So here's the 2 sublist. And we get 0, 1, 2 elements, so we'll get 13. And finally, 0, 3. So the 0 sublist and the last element will give us 2. So if you didn't follow along quite as fast, I see a lot of people were answering along with me, and that's good. if you weren't following along quite as quickly as I was doing it, I tried to kind of put in a little bit of delay, but sometimes when you're sitting alone talking to yourself, you tend to speed up. So anyway, let's run this function. And of course I added a 3 there. So let's run it and see what happens. Do we truly get the numbers that we expect? Oh, look at that. We didn't screw up. So that's good. Okay. Cool. So basically that's how you access things. Let's talk about lists with sublists of different sizes. So you can declare this weird list, for instance. So you see that I think most of these lists, except for the 0th and the element 3 or the 4th sublist, whichever way you count it, they both have 3 elements, but you see that this list does not have the same number of elements in its rows and its columns. So generally we call the first index, we call that the rows, and the second index, we generally call that columns. And this is traditional, just, you know, for various reasons. But anyway, so lists with sublists at different sizes. Yeah, so if you don't like this, you're not wrong. The reason why you shouldn't generally do this, well, it depends. I mean, I guess you can do this in various cases. There's some cases where you might want to. There's some cases where you might want to avoid it. The case where you might want to definitely avoid it is if you think that all the lists have the same size, and you run your program expecting that. So for instance, basically here, if we say for test list in weird list, you can use a for each loop to print out all the lists. So let me show you how that happens. I think it just wants another line there. Okay, so let's just print this out. Okay, so it's printing out every list. Let me just print out the list in total to show you that it will actually do that too. And then we'll print out here are the. So this is what it happens when it prints out the whole list. It's going to print out everything with the sublists included. So that's one way that it's going to do that. But when it prints out the individual list, it's going to print out each sublist regardless of its size. So the only problem with this is that it can pose a problem when you're doing like a for I loop. So for instance, if you say for I in range len weird list, and then for j in range len. So this current piece of code here will produce a bug. And then of course what I'm going to do is print out weird list at ij, and then I'll print out an end line here. So let's make the end equal to something like this. So in this example, it's going to go through and it's going to print out. Well, actually, what is it going to do? I think it won't fail. I thought it was going to produce a bug because normally how I produce this example, I would add more stuff to the first list. But you see here that the first list only has 3 elements, and all the lists have 3 elements. So when I do this, let's just see what happens. So what it's doing here is it's going through the range in the weird list. So the range in the weird list is 0, 1, 2, 3, and 4. So it's going to go up to from 0 to 4, including 4. So that basically this is like saying range 5. On the other hand, this thing here is like saying range 3, right? Because the length of weird list is 3. But if I had picked, instead of 0, if I'd picked 1, then the problem here is that some of these lists don't have 5 elements. So because they don't have 5 elements, what we're going to see is, I think, we'll get an index error pretty quickly. Yep. So you see that it printed the first set of things, and what it did was it kept putting the dot after each print, but it never made it to the next one because it expected that there was a thing in this slot, basically here. But there's nothing there, so it gave up. Okay, so how do we fix this? Well, the standard way is that you actually have to call this with the length of the weird list sub I. That way, you see I is the index of the outer list, right? So this is the outer list index, and you can say either, or maybe you would even call this the row index. And this is the inner list index, or the call index, or the sublist, or whatever, something like that. So if you do this, on the other hand, what it's going to do is it's going to look at the 0 list, and it's going to print out 1, 2, 3, because the weird list 0 has length 3. And then it's going to do the same thing for weird list 1, except weird list 1 has length 5, this one has length 7, this one has length 3 and 4. So this should do it, and it does. So you see now how you have to use, this is like a more general formulation in case you need the indices. Okay. So cool. And if you have any questions about this or any problems with this, you can always review it later, or you can I'll post the code to GitHub so you can have it as soon as I am finished with the lecture. Okay, so now what? So, I think the next task is to compute a determinant, maybe, of a 2x2 matrix. So this is just as a little example. So if you have a 2x2 matrix, so let me see if I can do this right now. Here we go. I couldn't get Liveboard working, so we're just going to use Photoshop for this, but it's okay. So let's see, let's hope this works. So if you have a matrix, if you have a matrix A, B, C, D, the determinant of this matrix is equal to A times D minus B times C. Now, when you take Math 221, you'll learn more about what all this means. The only thing I want you to know right now, the only thing I really care that you actually extract from this, is that you have to take this element, you multiply it by this element, and then you subtract this element and multiply it by this element. This is not to teach you linear algebra. What this is to do is to teach you how to access these elements in sublists. So keep in mind, if we have, yes, it does determine things. So if you have all these elements, remember that Python is going to store it like this, right? You're going to have your first sublist, and then your second sublist. So I think this is the eraser. Oh. Can I make the thing bigger? I don't know. Whatever. So, okay. So given this, what we're gonna have to do is, so what we're gonna have to do is determine where are all these elements, right? So that's really what we care about. We don't care about the actual meaning of this. So what we're gonna do is we're gonna say, well, the A is gonna be in matrix 0, 0, right? D, on the other hand, is in matrix, 1, 1. There we go. B is in matrix, and then here's the question. It's in the 0 sublist. So this is the 0 sublist. This is the 1 sublist. So this is in 0, and then it's element 1. And finally, C is in matrix 1, 0. Yep. And so let us make a function now that does this, right? So let's make a function, and we'll call it determinant 2, and it's going to take a matrix. And so what we're going to do is we're going to assert that matrix must be and it's going to return the determinant. So yeah, so I think this is actually a fairly good example just because it's more practice with indices. Anyway, okay, so sure, let's do it. So the point here is you'll take matrix 0, 0 minus matrix 1, 1. Oh, I'm sorry, that's not time minus, that's times. Minus, and then instead of retyping all of that, I'll just subtract, and then it's all the alternating ones. So it's 0, 1, and then it'll be 1, 0. And actually, we can just return this. Now, we assume that the thing is a 2 by 2 list of lists. If it's not, then it's going to give us some major problems, right? So it's going to give us, it's really going to cause some difficulty. Okay, so let's just practice. Let's print out and just see what this thing is if we call it with a bunch of different options. So what if we call it with this matrix, and then maybe sure. Nice. So let me give you an example of a, I think, so anyone know what this one will be if you consider the properties of this matrix? So you don't have to, parentheses are not necessary here because the multiplications are always taking precedence over that subtraction. Yep. So this one will give 0 as the determinant. Okay, cool. So I was thinking of doing the 3x3 determinant, but that might be a bit confusing. So instead, let's do tic-tac-toe first. So, let me see. Okay. So, how do you detect victory in tic-tac-toe? Right, so you have a board. Okay, let's draw that a little straighter. There we go. Here's our board. Now we're going to represent this as a 3x3 list of lists, right? Or alternatively, 2D list. Now, okay, so this is going to be row 1, row 2, row 3, or row 0, row 1, row 2, as the computer is going to index it. And this is going to be column 0, column 1, column 2. All right, so now how do we get victory in tic-tac-toe, right? So you have three options. Either you can have, say, XXX like this. So by which I mean, or you can have O. So basically what I mean is you have a full column, or you can have a full row, or the third option is that you can have something on the diagonal, or you can have the anti-diagonal. So I'm going to call this the diagonal, and I will call this the anti-diagonal. Okay. So, here's a question. What if we wanted to just do either row or column checking? How would we do that? Let's start with the simple. Well, let's start with the, I don't know if it's the simplest case, but it's definitely the first thing I'm going to do. So let's go back to the code and see how we're going to attack this. So if we have our tic-tac-toe function and it gets past a board, so the board is going to be a 3x3 list of lists. And I say list of lists, you can also just say 2D list. And it's going to return, say it'll return the string X if X is the winner, O if O is the winner, T if the board is filled but no winner, and it'll return empty string if board not filled. And no winner. So let's run through all this list and see how we can determine victory here, right? So we want to determine victory. Let's talk about the rows first. And I guess the question is, what do I mean by that? Yeah, let's check to see if in any given row there's a winner. So what we're going to do is we're going to have to do this with two nested loops. So we're going to say for say row in range, and we can say range 3, but let's just say range board. This will make it a little bit more general, but really this is range 3. And so what we're going to do is think about what you're going to have to do now. So if there's something in the first slot, so if there's nothing in if you draw a tic-tac-toe board where there's nothing in the first slot, even if you have an X and an X here, if there's nothing here, then what we know is that there's no winner, right? But if there's an X here, then even if there's an O here and there's an X here, we still have to check. Yeah, so your idea is very explicit. I think you're actually on the right track with the right answer, but we're going to do something a little bit more maybe general than accessing direct indices. So what we're going to do is we're going to set the current is going to be equal to the board at row 0. Now this, of course, is assuming that there is such a thing at row 0, that this sublist exists and that there's a 0 element. But whatever. So what we're going to do is we're going to assume that the input of the board is a lowercase x for x's, lowercase o for o's, and space, and I'm sorry, not space, but an empty string for, so empty string for nothing yet. Man, you guys were on me real fast this time. Yeah, you got to forgive me. You know, it's a brave new world. So, okay. So if current, right? And what does this mean? This just means if the current string is not empty. So in our case, it means that it is going to be X or O. Then let's check the column. So what we're going to do is if the current thing, then we'll say for yeah, let's just say for call in range len board, technically row, though of course this should also just be 3. If it's not 3, then there's a problem. So then what we'll do here is we'll just say if call is not equal to current, oh, that's not right. If board at row call, there we go, is not equal to current, then we're going to say winner, or let's just say current is equal to empty string. All right, so what does this do? Right, so what this is going to do is it's going to start at the 0 element and it's going to assign it. Then it's going to say if the current thing is not empty, then it's going to go through the second loop. In the second loop, it's going to check all the stuff in the row, and now it's going to check all the columns against the current element. If it's not equal, then we're just going to set it to empty. So what if we get through this loop and current hasn't been set to the empty string, right? So what does that mean? What that means is that, let's just go through 2 examples, or maybe a few examples. So let's see what happens when we do this. Oops, what have I done? There we go. Okay, so let us go back over here and look at a few examples. So what it's going to do is it's going to start in this row, and it's going to set current equal to X. And then it's going to advance to the next one, and it's going to check against this thingy, the O. But they're not equal, so this means that there's no winner in this row. So it's just going to set current equal to empty string. And then finally, when it gets here, it's not going to care. Current is going to be empty string, so it's not going to equal X. What if we get into this one? If we start here, then what's going to end up happening is current is going to start out is going to start out as the empty string. And so if you notice that I put in that little if statement, so we're not even going to check. And then finally here, let's put in an x in here to make it work. So what we're going to do here is first it's going to set current equal to x, and then it's going to check current against this one, which it is, and then it's going to check current against this one, which it is. So it's never going to set current to empty. And so what is it going to do at this point? Once we have all that done, and yes, I will now remember. Okay. So at this point, once we get through this loop, if current is still not empty, right? So if current is not equal to the empty string, then what are we going to do? We can return current, because current is the winner. All right. So this works for rows. Can we make something that works for columns? The answer is yes, right? How do we make the code that works for columns? The answer is we copy paste, right? Because rows and columns are the same thing, more or less. Python is not going to like this because there's duplicative code currently, but what are we going to do to fix that? So what we're going to do is we're going to say, now we're going to say for column in rangeLen board, and we're going to start at 0 call. And then here what we're going to do is we are going to, actually, technically this would have to be board 0, but it shouldn't matter. Then what we're going to do is do for row in rangeLen board. And so what we're going to do is we set yeah, so we can kind of flip everything in this way. So basically I'm just flipping rows and columns. I'm thinking, do I need to change this? The answer is no. And so this will do it. Now, if you're creative enough, there's a way to basically just merge all of this together into one for loop. The only problem is that if you name this row and you name this call, then you might be a little confused because you might have to use row as both a row and also a column, and vice versa. But anyway, okay, so now we've done the columns, same as rows, basically. Okay, so now we have two things left to do. They're both kind of the same. So now what we're going to do is we're going to say for I in rangeLen board, and we're going to check the diagonal and the anti-diagonal together. So the diagonal is going to equal board 0, 0, and the anti-diag is going to equal to board 0, 2. And so I want to kind of talk about, I think you guys might, it's similar to palindrome actually. What we'll do here is we'll say if board at I is equal to diagonal, I guess we'll say is not equal to diagonal, then we'll set diagonal equal to empty string. If board, and then here's the weird part that you'll have to actually figure this one out. And then after these, we will say if okay, so the real question is, I think, so this one should be a little more obvious, accessing the board at II, because it's always going to access the board at 0, 0, then at 1, 1, and then at 2, 2. But let's think through how this one's going to access the board. The pair I2 minus I. What is this doing? And of course, you want to say, okay, well, it's basically going to give us the anti-diagonal because it's what you called it. So why is this going to work? It's going to work because when I is equal to 0, 2 minus I is equal to 2, right? When I is equal to 1, then 2 minus 1 is equal to 1. And when I is equal to 2, 2 minus 2 is equal to 0. So it's always going to give us the 1 on the heading back direction. So for instance here, if we look at this thing, if we look at this anti-diagonal example right here, and we just make this a little bit bigger, and we write out what the indices are, this is the index 0, 2, this is the index 1, 1, and this is the index 2, 0, right? Yeah, so basically so you're right, as the column, as the row increases, the column decreases, so yes. Okay, nice. All right, so let's try this out with some boards and see if this works. Now it doesn't, the one thing it doesn't really do, which I might just not finish, I might just let you guys implement your own solution or whatever. I might not finish this in that way. So if it doesn't return anything, then that means that there was no winner here. So then we're just going to return the empty string at the very end. Now you might say, well, hey, we didn't check if the board was filled, right? If the board is filled, then there's not a winner, but it's also a tie, and we want to return T. But I think that this is enough code for this for now. So okay, let's run some tests on this. Let's make up some boards. Tic-tac-toe board. Let's say and let's say X, 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 and then yeah, let's make this blank, 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 say O blank, or let's put 2 O's in. All right, so what is this board supposed to do? And this also has to do with how we're going to judge testing. So in fact, let's actually do it this way. So let's write a def. Let's see, what function is it called? It's called tic-tac-toe. And let's put this code in it. Right, we hope that this is going to print out X. Okay, cool. So let's say if this is equal to X, we will print out row test passed. Else print row test failed. Okay, so let's see what happens. Nice. Now, if you're actually curious what it's going to do, we can also just print out the actual output of the function too. Of course, it's going to okay, so let's think of another test to run. So what about an anti-diagonal test? Let's try something where there is an X, let's put O's all around it, and then this would have to be an X, and I think there's no victory as long as anti-diagonal passed. So this is just testing out the anti-diagonal, right? And so we see here that if we kind of made this list a little bit more board-like, we could see that here we have the x's are winning on the anti-diagonal. So, okay, let's run this test and see what happens. Nice. So let's do this again. So here, let's test the diagonal. So I shouldn't say it's a good question. It's a question. So what is this code going to do? So we see that the diagonal is populated here with O's. So it's going to give us a diagonal victory. But also we see that the rows are populated. We have an O row populated in row 1. So here's the problem. Which one is it going to find first, right? If we look at the code, what's going to happen, right? So it's going to go through the rows first. If it finds a row that's a victory, it's going to return that row. And then it's going to return the column. And then it's going to return diagonals and anti-diagonals. So we see in this case that even though there's this victory along this row, it should return, there's a diagonal victory, it should definitely return, diagonals are last. So in order to fix that, let's just change this into an X. That way we're guaranteed that it runs the diagonal test, right? Because here, what if it didn't run the diagonal test? Then we wouldn't actually know if it worked. Oops, forgot to delete the print statements. Okay, better. Okay, so we see here that that worked. I guess the last thing to do is a column test. Let's do an O column test. So that we'll make this XXO, and we have to make sure that there's no victories here. So there's no victories here. I think the only victory is this O column here. So column test. Okay. No diagonals, no anti-diagonals. Looks good to me. No rows are all O's. It's just this one column. Okay. So let's run this thing. There we go. Cool. So I guess what I really am going to say about this is that this is the kind of example that we are going to do when you are required to do a testing document. So in the future, when we talk about your code, what we're going to do is we're going to ask you to write out a file where, or a Python script that will essentially call your functions. And it's going to call your functions. So for instance, if tic-tac-toe is part of your project, which obviously tic-tac-toe is not going to be a project since we've just gone over the solution. But if it were part of the project, then before you write the tic-tac-toe function, we're going to ask that you write this testing function. And what the testing function is going to do for you is it's going to say, well, I expect that given what I plan on writing, so it's kind of like a design document, except it's a bit more in depth. What it expects you to do is understand what you want to pass into the function and what you want to return from the function. And it'll test to see what things are going to happen. So when you make your project the first time, all of your tests are probably going to fail, most likely, or most of them are going to fail. But as you work on your project, more and more of your tests will pass until all of your tests pass. So for instance, in the next project, what we'll do is we'll ask you to submit a Python script that is essentially a bunch of functions that start with the word test, and then whatever the function's name is comes afterwards. And so the point is that you can write these functions, and then you can submit them as part of the project. So this is kind of the idea that we're working with right now. This is definitely an experiment. We hadn't planned on doing, so many different experiments with online teaching and this. We thought that this might be the most brave experiment we've done this semester. So, but I think we're still going to go forward with it just because I think it's probably more helpful than just a design document. The reason why is because it definitely makes you think about what the functions have to return, and it makes you determine what is successful and what constitutes a failure for your function. All right. So anyway, okay. Let's see, what other kinds of examples of 2D lists can we do? So, what about a maze function? Yeah, let's call it maze walking. And it's going to take a maze. And the maze will be a 2D list. So let's just declare maze out here. So I'm going to show you something that you can do kind of with 2D lists. It's a little bit delicate because you can't modify them. But anyway, here we go. So let's say that if something is a... so let's define how the maze should work. Let's say if you reach... Let's do it like the homework. So G is the goal. And let's make forbidden positions. So an asterisk is a forbidden position. So basically what we're going to do so that'll be a forbidden position. So, and then space, I guess. A space is a regular position. Okay. And now we get to see if I can do this in real time. So, let's make let's make it something that I can actually see. So let's make it an X, or I guess that seems forbidden too. Let's make it an underscore. 2, 3, 4, 5. And then let's make that, and then let's make that. I think, okay. So in terms of project 1, you are not required to write a testing document. The reason why is because we hadn't described them yet, and we hadn't said anything about them yet. So, and we hadn't written into the project description. So no, but that's why we're talking about it now. Okay, so I've just built a maze, and so you guys remember. So let's just say while, let's say you start at position, let's make it so that we start at a legal position. Let's make another. And let's start at position. So you guys are going to think this is very similar. So, right, so this is almost the same code as you wrote in the homework assignment, except now we're using, the only difference between this and between the homework is that there were no forbidden positions, so you didn't have to care about anything except for the boundary, right? So here, in terms of the maze positions, what we can do is we'll say, okay, so how do we get the position? So let's say, there we go. And so let's print out the maze. Yep. And let's print them all in separate lines. So we can say for line in maze, print line. That should print out the maze. That's like calling the print maze function. We're not going to do any error checking because we don't care. So in this case, what we're going to do, we're going to say if, say, maze, well, let's say if position x is bigger than 0 and WSD is equal to, what is it? I guess W, then we can do position x minus equals 1. Elif position x is less than, what is it going to be? Length of maze. Yep. Minus 1. And WSD is equal to S. Then we're going to add 1 to the position. And then we do the position Ys. So I should say that position X is the rows. So position X actually goes down and up. Position Y is going to go left and right. So maybe that's a little bit misleading, but unfortunately that's what I've done. Of course, maybe I'm wrong, and so theoretically you've written most of this code already. And so that is D. So what is this going to do? What this is going to do is it's going to basically move us around. But here's the problem. Here's a problem. If we haven't checked for forbidden positions yet. So let's just say and maze position x minus 1 position y is not equal to star. And now we have to copy paste this into all of them. So here we're going to do +1. And here we're going to do -1. And then here we're going to do +1. Okay, so that's just checking for forbidden positions. Now, of course, here we're actually not going to be able to print out where we are unless we do something else. So here what you see is that the maze is actually equal to not a 2D list, but it's equal to a list of strings. Now, let's see if we can run this thing and see what happens. So now technically we are here right now. We're in the 0, 0 position. So I think what we have to do is go D first. And now we're here, even though we can't see our position. And now we have to go down a bunch of times. So let's do that a bunch of times. And then we reached the goal. So we couldn't see our position. So how do we fix that, right? We can't just print out this maze anymore. We have to figure out if the player is in that line, right? So instead of printing out for line in maze, we're probably going to have to do a for I in range len maze. And then what we're going to have to do is if position x is equal to I, then we're going to have to print out something else. So we can't just print out maze I, right? What we are going to have to print out is, let's do it this way. Let's practice slicing. We'll practice slicing by doing maze from 0 up to position Y. And remember that a slice goes up until position Y, but doesn't include. And then we'll add on, say, a character symbol called P. And then we will add on the rest of the thing. So maze from position Y plus 1, colon. And remember, maybe I won't use X. There we go. Okay, so let's see if this works. So this slicing business is a little bit nasty. I don't disagree. But it's a quick and dirty solution. So let's see if this thing works now. Oh, excellent, excellent. What's the problem? It says that I didn't access the position X. There we go. So let's check to see what's going on here. Right? So let's say that we want to go, let's try to go down first and see if this will actually detect the bad positions. Yep, it did. Here we go. So now we can move around. Cool, so we went too far down, so now we have to go up by 1. And then we have to go back a few times. And then we have to go down to the target. Okay. So if you look at this, this is like a good example of how the homework problem that you did can be modified. And of course, the homework problem used a function, a special function to print out the thing, and it used a special function to input the thing. But this is just so quick and dirty, right, that I didn't write those functions. This is basically the way to consider a grid if you had forbidden positions. The only other thing to say is that if you ever had to modify this list, the point is that you can access all of this as a 2D list, but you can't modify the maze. You can't modify the maze because strings are immutable, which means that you can't change them. And I think I said that before in class. Let me just talk about what that means again. So if I have my favorite string is the word in queuing, and I decide that what I'm going to do is I'm going to say my favorite string of 3, right? And I'm going to print this out. There's nothing wrong with that, so it's going to print out just fine. But what if I say, well, first let me actually just print it out. So my string at 3, so 0, 1, 2, 3, so it is a U, so that's right. But what if I do my string of 3 is equal to T, right? Well, theoretically, if this were a list, what would happen is it would go to the 0, 1, 2, 3 index, and it would replace this with a T, right? But I think you've seen what happens when we do this, right? It says type error. String object does not support item assignment. And what that means is that strings are immutable in Python, and you can't actually change them. So if you want to replace a character, for instance, there's a number of ways to do it. One of the simplest ways to do it would be to do it this way. So you can say my favorite string is, or let's say call this my other string. so let's comment this out as bad. Yeah, so slices are kind of the best of the worst ways. So you can say like 0 to 3 plus t plus my other string. Oh, I'm sorry. Has to be my favorite string. From 4 to the end. And now we can print out my other string. Okay, so that did what we wanted. This is pretty gross. Right? I mean, I think that there's not a lot of good excuses for what this thing is doing. I think it's generally pretty awful. In your future life. So this is currently forbidden arts, right? You can use my favorite string dot replace, and you can replace a u with a t, and then. Well, oh, actually, this is a great example of the immutability of strings. So let's see what happens. So let's comment out this slice thing so we don't get confused about what's going on, and let's run this again. I ran a replace function, which does exist, and it ran, didn't crash. So it ran on this, but it didn't change my favorite string, right? Well, why didn't it change it? I just told it to replace. Well, as it turns out, my favorite string can never be modified, right? So my favorite string is truly immutable. So what you're going to see a lot of the time is people will do this kind of thing. And if you do this, then you're not actually modifying the string itself. What you're doing is you're taking the return value and you're replacing that whole variable name with the new string. So this is giving you a new string and you're replacing it. So this is actually not modifying the original string. This is just replacing the entire string with the new string. So here you'll see that in this case what it's doing is it's actually replacing both of the u's. So this replaces both u's. So actually not quite what we want anyway. You would have to do something a little more complicated. I think in the replace method. So actually, yeah, replaces all of them, unless of course you do. Let me try to see if I can get the autocomplete. Yeah, so there is a count. Yep, I thought so. So in here, if you put a count in, this is the maximum number of replacements that it's going to do. So I think this will do, yes, this will do what the other thing did. But you have to know about this other argument. Normally this other argument, if it's not set, then it just replaces all of them. If you set a limit, then it does that. So anyway, so don't use this function. In fact, the good news is you won't have to use, this function's totally useless for at least the first 2 projects, and maybe we'll allow you to use it for the 3rd project. So yeah, so the good news is it's technically forbidden, but if you're using it, you're doing the wrong thing. So anyway, so basically Python does have ways to kind of short circuit the weirdness that Python forces on you with the immutability of strings. Clearly they have like a replacement function. They do a number of things for you like this. But yeah, we do not require you to use this on any of your current assignments. All right. So yeah. Okay. Let me do one last example. Yeah, I might try to write up more sample event files and stuff maybe today. It's not actually that hard to write them up. I just have to spend the time to do it. It takes some time to write them up because they have to actually work without errors. Okay. So I guess I'll leave you guys with the challenge problem. And I think, so if I pull up the schedule, let me actually do that. Where is the schedule? Okay. So the current schedule has us here doing modularity and testing. There's a modularity and testing lecture that you can look at. I decided to do really more 2D list stuff today. Next lecture will be binary and hex. Project 1 is due then. Project 2 will be released then. So those two things are still true. The one thing I do want to talk about is the exam, which is supposedly next week. What we're going to do is we're going to flip this week and lecture 18 week and lecture 19 and 20 week. We're just going to flip those so that you guys and us both have sufficiently long time before the exam shows up, and so that we have time to prepare what the exam is going to be. So yeah, the project. So this schedule was made. Yeah. So this project was made before. Or, I'm sorry. This all of this was made before everything happened, and so I was a few days late getting the project out. So we might have to shift the Project 2 release date back a few days, etc., etc. These guidelines are based on the old schedule. I haven't fixed it yet. Okay, so the thing the thing about the exam is that we're thinking what we're going to do is we're going to give you some kind of like multiple choice type thing that'll be worth 25 points. The exam in total has to be worth 125 points. So we're thinking what we're going to do is give you maybe something that resembles the previous exam, and then we'll give you essentially some coding problems and some basically it'll be like a homework that you'll have to submit. So that's the exam's coding problems are just going to be submitted through the regular GL submit system. And we might give you some coding files to debug. And so that's how we're going to do the debugging and the coding section. And so because we're going to take out a lot of other things on the exam, like code evaluation, since you could just copy paste whatever code we gave you into PuTTY or PyCharm, I think what we're going to do is probably have just like maybe 2 debugging questions and maybe like 4 coding questions that just cover the same material. So instead of doing coding evaluation, you'll have to actually implement something. So that's what I'm currently thinking. And that's why we're taking some extra time so that we can get the format down and get you guys set up with all of that. Okay. Yeah, I think that's about it. It is 2:14, which means that class technically ends in a minute. So I think that's it for today. I'll upload the code to GitHub, and then we will end the lecture. So I definitely don't want, the only thing about the exam that I'll say is that I don't want I definitely don't want there to be a lot of extra work, because supposedly you're going to have homework project 2 tests due the same week that you're going to have your exam. Now actually, if it's due on Monday, then we'll make the okay, well, I guess we can just kind of, yeah, we'll just push project 2 stuff until the Monday, and then we'll do the exam, and maybe the exam will just be due on Friday. Okay, so I think that'll settle the schedule. I just don't want to have multiple things due on the same day. That's why your labs are due on Thursday instead of Friday, because Since your project's due on Friday, I assume that if you forgot to do your lab, that basically everybody would just not do the lab and focus on your project, which is not what I want. So, okay. All right. I think that's it for now. Thanks, everybody. Have a good rest of your day. How much time will we have to do the exams? So you'll have basically, I think I'll release the exam on maybe Wednesday, and you'll have until Friday. So you'll have like 2 or 3 days to do the problems. The project is definitely due Monday. As I said, all of these dates are from before the... I mean, if I update the schedule, then I'll just update the schedule. I'm not going to email it out. Okay. It is due Monday. Oh god, I'm creating too much confusion. Go with what I say. I am saying that the project is still due Monday. Okay. Yeah, and I guess the last thing to say is... I guess I'll just have to hook up my old webcam to get Dog on, because there's no timeline on when my new webcam is going to get here, unfortunately. All right. I think that's it for now. Yep. Okay. Let's try this.